So, what exactly do these scientists do? I'm picturing tiny tadpoles with 3D glasses munching on popcorn, but I have a feeling it's a bit more complex than that.
You're not wrong about the tadpoles part at least. They're the stars of this research. But it's their brains and how they process moving images that take center stage.
Okay, so we're talking about the tadpole visual system, but how do they even study something like that?
Well, they use this really clever technique involving something called sparse noise stimuli. Basically, they showed the tadpole a series of flashing pixels on a screen, and then through some very sophisticated analysis, they figured out which patterns of pixels cause specific neurons to fire.
So they're mapping out what each neuron sees, its receptive field.
Exactly, like a window into the tadpole's visual world.
Yeah.
And for a long time, we thought these receptive fields were pretty simple, responding to things like light and dark spots.
Right, like edge detection, that kind of thing.
Right, but Hiramoto and Klein discovered that certain neurons in the tadpole's optic tectum were responding to much more. They were reacting to entire sequences of images.
Hold on, so you're saying these neurons are recognizing patterns unfolding over time, like mini-movies?
That's exactly it. And what's even more fascinating is that some of these neurons are tuned to very specific types of motion.
Like what? Give me an example.
Well, some respond really strongly to rotational movement, for instance. And get this, they even exhibit preferences for clockwise versus counterclockwise motion depending on the speed.
Whoa. That's not just basic motion detection, that's understanding the nuances of movement, the sequence of changes over time.
What's truly mind-blowing is that even the timing of these movie-detecting receptive fields can be modified through experience.
Were you saying that the rhythm of this neural orchestra can actually change? Like if you expose the tadpoles to different types of visual experiences, their brains will adapt and retune themselves?
You got it. They actually did an experiment where they trained these tadpoles by repeatedly showing them stimuli with different time intervals between on and off signals, kind of like flashing lights with different rhythms.
What happened?
Well, they found that the tadpoles' brains adapted to the specific timing patterns they were exposed to.
So it's like teaching the tadpole brain to dance to a new beat. But what does this tell us about how the brain processes information?
This is where things get really interesting. The researchers believe that the OFF signals might be acting as markers for event timing, while the interval between the ON and OF signals encodes the duration of the event. Imagine it as the brain learning the rhythm of its visual world, allowing it to anticipate what's coming next.
So even a brain as seemingly simple as a tadpole's is capable of incredibly sophisticated temporal processing. This is absolutely incredible. And this brings us to the question that I'm sure is on all our minds. How did they translate this biological brilliance into an AI system?
That's the most exciting part. They called their AI system MovieNet, and it's all about mimicking the way these tadpole neurons encode visual information. To test MovieNet, they showed it videos of tadpoles swimming under the influence of different drugs that alter their behavior. The AI's task was to analyze these videos and identify which drug each tadpole had been given.
So it's like a tadpole sobriety test, but for AI. But seriously, what were the results?
The results were astounding. Not only was MovieNet able to accurately classify the tadpole's swimming behavior based on the drug they'd been given, but it also outperformed human observers in this task.
Wow. That's amazing.
Yeah.
But there's more, right? I remember reading something about MovieNet requiring less training data and computational power than traditional AI algorithms.
That's right. MovieNet required significantly less training data and computational power than existing algorithms like AlexNet and GoogleNet, both of which are considered giants in the world of image recognition.
This is incredible. We're talking about a tadpole-inspired AI that's not only more accurate, but also more efficient than some of the most advanced AI systems out there. This has to have huge implications for the future of artificial intelligence.
Absolutely. The mind-boggling potential of MovieNet and what it might mean for everything from security and medicine to maybe even predicting the next viral TikTok trend.
Stay tuned, fellow esoteric masters. We're just getting started. It really makes you wonder what other secrets are hidden within the natural world, just waiting to be uncovered and translated into revolutionary technology.
Absolutely.